We're on the final stretch now, so we've got our panellists today. Just have a quick chat about where we are and where the industry is going, and just chew the cud a little bit. So one thing that occurred to me earlier was that the industry certainly seems to have turned a corner in terms of IP. It was only a few years ago that we were talking about IP was the next big thing and SDI is dead. And now I haven't seen an SDI is dead for quite some time, but IP seems to be everywhere. And I keep trying to convince myself there's still a place for SDI. And I think that there is in certain sort of fixed installations. If you have something which is not flexible or scalable and you just want to build a system which is very straightforward and easy, you would use SDI. But anything more than that, then you're going to be looking at IP. So if I could ask the panelists, what's your views on actually having turned a corner? What's your gut feeling? So Paul, do you think we've turned this corner in technology and the world is now IP?
That's an interesting question, isn't it? So in some respects, yes. So for larger systems, certainly. And I think it's always been about economy of scale and the size of the system that you're installing. If we're looking at building small solutions, and when I say small, I'm sort of 40 squared router territory, then it doesn't make any sense to move into IP. The cost of entry becomes too high. So there's too many barriers there. So we need PTP generation, we need the switches, we need and so that doesn't make sense. But when we start looking at larger systems, it's interesting. In a previous life, we used to say to people, yeah, the crossover point's at about 1,000 squared, and that was 3 years ago now, roughly. And when we look now, I think the crossover point, depending on what you're trying to do, is around the sort of 300-400 squared mark. So I think it's very much a case of making a decision based on the scale of what you're trying to achieve. And yeah, certainly for large systems, the systems that we're looking at, it's almost it's not a question. It's not like, oh, well, we're going to build this one out of SDI. That doesn't come up at all. But in smaller solutions and in smaller systems, then yeah, I think it becomes quite an interesting question.
Yeah, because I think, Phil, you made the point earlier. You said when you were getting tenders, you used to be sort of SDI and IP so you could compare, and now it's just IP. Is that the case?
Yeah, I think if you go back 2.5, 3 years, almost every single one people wanted both variants. To understand where the break-even point was, and I certainly in the last year and a half I haven't seen that. Customers have an idea of what they want to do. Yeah. They just want to see a clear plan of how they get to what they want to achieve.
Okay, and how about you, Jared? What are your thoughts?
I agree with everything that's just been said. I think what I'm seeing is people are starting to see what they can do with the flexibility of IP, and once you offer them the opportunities to use an IP infrastructure, to be able to scale it, to be able to connect it seamlessly, to be able to use just vanilla IP everywhere. Actually, it's a bit like when you go and buy a telly, you're going to spend 400 quid, but you end up spending 600 quid because you've been talked into something else. It's not quite the same, but people are upselling themselves. Once they decide to go IP, they're talking about, well, can I build a 1,000 square 3 gig router? Yeah, of course you can. It looks like this. Oh, what happens if it was UHD then? Well, it looks like this. What happens if it was 3,000? I mean, I have conversations where people have talked themselves into 10,000 square router, which nobody's ever built in SDI, but they found a requirement to do it. They found a need to do it, and so, that flexibility, I think, is enabling people to see more value, and I think that is like a positive feedback. They've kind of mentally decided IP might be okay, and suddenly they see what they can be doing with it in the future. And so I think we have turned a corner in the sense that whilst there's still a very big differential in people's knowledge bases and whether they're capable of installing these things, how much help they need to do that, actually there's plenty of examples, TPC and CBC Canada and reel off tons more, NEP. There's tons of places where people they've done it, they built it, it works fine, nothing wrong with it. And those people have kind of proven that you can get on with it, and I think that's kind of making everything a bit more positive.
And Daniel, coming from the sort of more IT perspective, I mean, how do you find coming into broadcasting? How is it as an industry for you? Does ST2110 feel as if it's a well-defined standard, or do you think we're still trying to find our feet?
Well, I think that coming from the IT world, we see that the broadcasters have the same problems to solve as other industries already had. Just name them differently. It's always the same task. It's always the same. Well, from a timing perspective, the same problems to solve, but from a different perspective, but the same goal in the end. And it's good that the broadcasters have decided to rely on an existing standard rather than writing something completely new. And I think they can make a benefit out of it because let's call it the child illnesses of PTP have been solved, I think, by other industries that have painfully gone through this path already.
Yeah. And it's a proven technology, isn't it? Because PTP has
is.
been around since, what, 1980, 1989?
No, it's since 2002,
2002.
the first version, but it was not adopted that well at that point, only in labs, and it was originally created for the automation and control business. So robots should communicate among themselves in a big facility, for example, in the automobile factory to communicate with PTP. But then the telecom people stepped on of it, and they drove the development of PTP version 2, and then others came along.
Okay. And Norbert, how about you?
I think you talk about mentality, and like in every new technology adoption, there is a curve with the pioneers and so on, that they just run with the new technology, they try to see what they can do and so on, and they learn on the way.
Yep.
And I think there's been lots of discussions which are now almost properly settled from the standards, and then thanks to some of the pioneers as well proving it works. So now people are much more inclined to say, okay, the standards question almost solved with ST2110 and NMOS.
Yep.
System working, CBC, RTL in Luxembourg, SIC in Portugal, NEP, all these things are proving that they can use the technology, and I think beyond that, there is a business case.
Yeah.
Now to the initial question, whether SDI or IP, that's also depending on a business and amortization process of some of the customers. There is no point of throwing away 2 years old or 3 years old kits which are still not amortized just because of IP.
Yeah.
So there will be the greenfields, there will be the refurbishments of the upgrades, where the technology can be introduced, but only if it brings a business benefit. Because the starting point is going to be anyhow, at some point, 10 to 30% more expensive from an investment point of view. However, the flexibility, or the case of UHD, where building a 1,000 square UHD router, I don't think it's even possible today, technically, you have to go IP anyway. So this is where, anyway, at the end of the story for all of us in terms of vendors, customers, system integrators, it's a business decision that has to be made. So SDI will still have a good old days coming along on the way for amortization purpose, for ease of operation as well, for small flyaway systems. Sometimes it's much, much more pragmatic to go 3G or 12G SDI for a small system. Then, yeah, if you have a greenfield today, I would think IP. But if I plan it, as we discussed earlier, in the way I plan an SDI plant, I won't prove to my board that I need to pay that amount of money.
Yeah.
And that's where, again, the mindset going to be a very, very important evolution to go through our industry, because the problem is not technology. It's architecture for the planners, the engineers, and operational with all the tools that we've shown and discussed on how do I keep my operations as streamlined as possible, as flexible as possible, because IP delivers these benefits. But if you don't have the right controls, then you're going to get any ROI in the end.
Okay, so within the sort of limits I spoke about SDI, do you think that there is still a place, or there will ever be a place now for 12G? Is it just a case of, why wouldn't you go IP if you're going to go to that sort of bandwidth? Phil, how about you? What do you think?
I think you'll still see it with small systems.
Yeah.
I think there's even parts in an IP system, like a monitor, where I need to just get it back.
Yeah.
It's better to put it back as a single 12 gig coax than it is to do quads and deal with all potential timing alignment issues with it. But I don't see 12 gig going away. I think it addresses a much smaller end of the market in terms of fly packs, customers that have just a set way of working, they prefer to be that way, versus the kind of workflow-oriented larger systems.
Yeah.
But in terms of increasing in new products and scaling it out to be 1,000 square, I don't see that happening. I don't see somebody introducing a new SDI router up to 1,000 square with 12 gig SDI on it.
And you don't see it something you pursue at all? So because you're for IP now, why would you go SDI?
I think Phil's right. Very much depends on how you're looking at it. So there are companies out there building 12 gig and large scale 12 gig routers. But when we say large scale, I mean, just sort of, I'm not aware of one above 500 squared. I think it very much is a question of it's based on the project, and we have to be aware as well as an industry that there are a number of people who tried to adopt earlier standards in IP and failed, and so certainly again, previous life saw tenders saying this must be SDI.
Right.
No, so certainly from Middle East and from American customers where they'd effectively tried to do something in IP. It hadn't worked for various reasons, and instead of looking at why that was and looking at all of the success stories that exist there, they're effectively saying, well, we tried that, it didn't work, so now we're not going to do it anymore. There's this 12 gig stuff. We understand SDI. It's a cable. I can plug it in, and the Luddite in me quite likes that in some respects. I mean, gone are the days where it doesn't work. I'll unplug the cable.
Yeah.
I'll plug it into my analyzer. Is there a signal there?
Yeah.
And of course, all of that is lost when we start looking at IP.
Yeah.
And but.
Especially when you have control systems, you get the data going backwards and forwards, and if it's not receiving a response, it's going to behave differently than if it is connected to something, isn't it? So,
well, I mean, as Gerald will tell you, when you take the SFP out the port stops talking.
Yeah, a bit of the Schrodinger's cat thing. It's okay. I think it's interesting what you said, Gerald, about it's almost now that we seem to have got to the point where IP, I hate to say it, but is a de facto standard. And companies are starting to flex with things like, I was talking about earlier about flexibility and scalability, which I see as the true drivers for IP. I mean, what sort of experience do you have with that, seeing customers moving to flexing? What are they doing to try and flex the system? Are they virtualizing? Are they building bigger networks? What is it they're doing?
At the moment, they are, I think people have got some very interesting ideas about what they're going to do next. But in general, what they're doing right now is they're just making sure they can build a 2110 AES-67 Dante Ravenna infrastructure that replaces what it was they had before, if it's a tech refresh, or what it would have been if it's a greenfield site. But and I see the full spectrum from very conservative view through to very forward-thinking view. But what I am seeing is people starting to put in more data center-like infrastructure, right, so that they can consider using the network for more than just 2110 later. Once you have SDN, some sort of orchestration over the top of that, you can layer any other IP technology you feel like. So you could, and some people look at this and think, well, why would I do that? I built a 2110 network. I've decided how big it is. That's how big it needs to be. Why would I risk this not working? And that's a fair point. But actually, the cloud data center guys are doing this all the time. Their networks they have a physical network, and it provides 20 different virtual functionalities. It's delivering 20 different sets of functionality separated by tenants, multi-tenants, securely across as many different applications as you could wish for. So if you're, and going back to the previous answer, what I'm seeing is bigger and bigger and bigger aspiration, bigger networks being built, massive, in a data center sense, not big, but in the 2110 sense, really getting very, very big indeed. I mean, we are starting to see systems which need 400 gig spines to flex the size they want to get to. Right. And so once you're building that sort of data center, it makes sense to ensure that you're going to use it all the time, doing something. And that may be 2110, but if it's not 2110, it might as well be something else. You might as well be using it for editing or transcoding or subtitling or something. And once you can protect those 2110 citizens, you can add VXLAN or VMware or blah, 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 blah. You name, I can reel off another 100 TLAs, and you could stick that on your same network as long as you protect it. So that's what I'm seeing people do within the data center, having aspirations to do that. And I'm seeing people, and there's one of them, who are looking to connect all of their data centers together in a way that makes them transparent and interoperable and available, functionality available everywhere. So, the NEP Australia, the Andrews Hub, virtualization, anyone, anywhere, is exactly what I think the forward-thinking guys are doing.
Norbert, is that your experience as well?
But I come back to the business case once again as a starting point, because this is where these guys are asked now to be more and more efficient, because they cannot over-provision anymore. The NEP Australia case is that you build a truck which is supposed to do the massive football games, 40 cameras with all the massive vision mixers. When it's on the road, it's kind of a sleeping capex. It's money which is sleeping, and that's big money. Nowadays, as we say, they can build medium trucks. We can really work Monday to Sunday and absorb the peak of productions through these data center models. So we are not yet, when I talk with my pure IT colleagues and I talk data center and so on, I think virtualization, we are not there yet in the live production processing. Monitoring, distribution, play out, and so on, yes, we can virtualize. But again, it's always how you bring the technology at the service of a business case, which as of today, our industry, through the major change we are facing in terms of the content consumption, the fragmentation of the audiences and so on, brings then the pressure on the budget to the content providers and then back to us manufacturers. We have to find ways to be more intelligent, more flexible, and over-provision the less as possible.
Yeah.
You say data center is a concept where you want to use your resource 24 hours a day. So when Australia is sleeping, Europe is awake, and maybe can work with it. And this is where, again, for global organizations like NEP, it's even further benefits because they work on all the time zones and they can almost leverage that 24/7. But there are organizations from the traditional OB companies, again, when the truck is on the road, it's a sleeping capex. So the much more you minimize that part, the better ROI it is for everyone. And in the end, for the production companies that are putting a huge pressure, they didn't pay the premium from going from SD to HD. Now from HD to 4K, there is a bit of a premium which is paid, but to democratize 4K as a mainstream, no one will pay the premium. So they have to find other ways through technology to make that happen. And this is where, again, IP data center models and shared resource is the way to go.
So this is more of the agile type of approach to business we're seeing now, especially in software, build what you need as opposed to over the provisioning. Because one of my arguments for IP is that you don't have to think 5 years or 10 years ahead of what your system's going to look like. You just build it for today or the near future, and then you can develop it as you go along. But Daniel, there's something about PTP. We were talking about, I think it's V2.1 you introduced earlier. And I'm just wondering how expandable PTP is, because I remember reading a chapter in the original 1588 book, which said worst effect of PTP was never designed to work over a WAN. So what's changed? I mean, you spoke earlier about how we do that technically, but do you think we're now in a position with V2.1 to be able to expand throughout WANs and big WANs?
No, it's not a feature of PTP version 2.1. It adds some other features. But you're right, PTP was not designed to work over a WAN, but already the telecom people in 2008 said we need it over the WAN.
Right.
So luckily they did it in the first place for frequency synchronization only, and therefore it was not such a big effort to implement this also over non-PTP compliant networks. But when it comes to phase and time of day synchronization, especially phase synchronization very accurately, the networks have designed in a different way to complete with that. And this is not a question of the PTP standard, it's a question of the hardware support of the network components.
Okay.
PTP version 2.1 adds one interesting and important point to it. It is security, because it will come into the standard that masters and slaves can authenticate and make a secure path between each other. There has just formed a security group within SEMT, which turns out to be maybe not necessary to group when you look at the ongoing work at the IEEE for the upcoming PTP standard. So security is one of the features that will come in.
Okay. I've been avoiding the S word. But that's one of the big advantages of SDI, because you know when somebody's hacked your SDI network because they have a pair of wire cutters in their hand. I mean, the challenges we have for IP networks is that somebody could literally be hacking your network, or you could have some rogue software running on it. And I think this is to say something we're going to take a look at again. Probably not today, because we probably need another day to do that. But I'm interested in the mindset as well. So we've spoken about mindset and this sort of argument: is it better to take a broadcast engineer and turn them to an IT, or vice versa? And I purposely avoid having that conversation at all costs. But there's been some quite strong views today. Phil, can we start with you? Why do you think broadcast engineers are better adept to learning IT than vice versa?
I think it's the mythology. If you look at a broadcast engineer, and generally the skill set of being able to fault find through a system and primarily go back through it, I think that's very well adapted to where we would have to try and find where the fault sits in an IP network, where it could sit in multiple areas. I think when you look at the IT, people coming in from the IT space, there's a heavy reliance on, there's a lot of software and self-healing that will take care of it for you, and that it's all going to come good. I think in the broadcast space, the tools are coming online. They're just not all there to do it today. But you still come back to the device sat at the end of the network. You still need to understand how that device behaves and what it does. Because if you don't, it may not actually be the network. It may not be the optics or the actual or the PTP. It may actually be the device that's sat at the end of it, which is causing the problem. So you really have to understand the entire path of the facility and how everything operates in it. And like I said, we've brought in people from both sides of that into Lavo on a sales, engineering, and also on a support. And we generally find, whilst we have the need for IT people to go and program the switches during the configuration and get some of the initial equipment up and running, actually for the support side of it, we find that it's adapting the traditional skill sets to accommodate that additional work. And we need both, but I would vote that we brought in broadcast engineers and trained them correctly on how to manage the network and fault find it than the reverse. I think there's a lot more involved in that, I think, from a company perspective and from a training program.
Okay. And Daniel, from sort of the IT world, have you had to learn broadcasting, or is it only a small subset you need to know to make timing work?
Sorry.
From your point of view, how much broadcasting have you had to learn to make to be successful in this business?
The good thing is that I'm coming from a broadcast background.
Right. So that answers the question.
Personally,
yes, yeah.
Because I studied media technology and was working for ZDF, German television, for 3 years, and then changed to Meinberg. Yeah. A long time ago already, and then the broadcaster started to look into PTP. So for me, it's a little bit going back to the roots. So for me, it was not a big issue, but I think it is like all the others explained, an issue for the IT guys to get along with all those terms that the broadcasters deal with.
Okay. And Norbert, how about you? What are your experiences?
I have different experience, but one thing which is true is that change management is always kind of the same curve. Whether you do an organization change into a company and so on, when you change people's roles and so on, you always go through a curve where there is the first question of why do we change? And with IP and technologies and so on, with lots of new terminologies, way of thinking, architecting and so on, you have to digest that first. So you go at the bottom of the curve where it's too much. And then you start to understand the opportunities. You get this type of conference, which brings as well a level of confidence, new ideas, answer some of these questions, training, we talked about it, and so on, which you go up the curve. And then you see all the opportunities opening up. And then the level of confidence goes. That's one thing. The second element is that, yes, for sure, I believe as well broadcast engineers might cope more easily with IT technology. However, I'm always pragmatic among the people I have around me, and I've seen very good IT engineers understanding broadcast as well. And I think it's not a black and white rule. Look at the people you have around you, test them in terms of mindset, and one thing you will never do, and I faced it internally in Sony, is that if someone doesn't want to learn, you won't make him learn. So have people who are curious around you, who are ready to learn, and then you will get on board. And whether they're coming from IT, from broadcast, from software, from hardware, wherever, if you have people that are willing to learn and embrace the change, then you will move forward. And I think this is, for me, most of the people's rule rather than where they come from and so on. IP in the end.
So
I'm a network engineer, so it's not so complicated. I'm not so smart.
So it's the attitude of mind is as much
the
as
state of
important.
mind is very important, and this is where, again, I started with the curve of the change management, because it's the human being which is like that. How bright you are, or confident you are, self-esteem, or people around you as a team, you always go through a moment where you question yourself of the purpose of the change. And it's true, again, I've been with my own team several times where they question the relevance of IP. That's the first question which people ask, why do I have to change?
Yeah.
And then you start to say, you have to change, trust me. But still they're questioning themselves. And then they realize how much they have to read, to learn, and so on. But there is a ticking point where, okay, I got it. And then I can tell you it's almost a Dirac. It goes straight to self-motivation, they learn. But you have to convince yourself first.
Okay.
So it's very people-based.
Okay. And Paul, from going from the sort of design and installation phase to the now making it work and support and sort of maintenance phase, I suppose I call it, what kind of engineers do you have? Are they mainly broadcast engineers moved to IT, a bit of a mix, or?
Certainly we have, as a company, we have a huge mix. And I think one of the, and I think the key point is a lot of it comes down to attitude. So if we look in the UK, there aren't any IT engineers who are supporting the broadcast trucks. They've been on the road now for the best part of a year, and with sort of minimal issues. But the guys who are running those are guarantee engineers who've been running trucks for 4 or 5 years, if not longer. And I think the interesting part there is that's almost a direct opposite of then what we have in the Netherlands, where we have IT people, and they are IT people, and then you do find yourself saying, no, but it needs to work like this for these reasons. So you're then arguing a broadcast case to someone who's not necessarily looking at it in that way. So we certainly have a mix, but. Yeah, I mean, as a general thing, I suspect that the reason why we're all saying that an IT engineer is not as good as picking up as a broadcast engineer is that the number of people who are IT engineers is far greater than the number of broadcast engineers, and we have to accept that there's with a larger pool of people, there will be a larger a distribution of talent amongst those people, and there will be some who just don't get it and can't pick it up, and there'll be some who can pick it up and run with it without any issue. And but certainly, yes, I mean the challenge is there, and who do you employ, yeah, if anyone knows a real answer, that'd be useful.
Okay, just before I ask my last question of the panel, does anybody in the audience have any questions they'd like to ask?
Tony, can I have a go at that one?
Oh, of course, sorry, yes.
I think that's a fascinating question.
Yeah.
And I had lots of answers lined up, and they all changed as different people spoke.
Right.
So I think there's an interesting, I mean, I'm a broadcast guy that became an IP guy, and I choose my words wisely. I'm not an IT guy, I'm an IP guy, and maybe that's part of where we're getting confused. The IT guy is the guy that makes sure that the servers work and you've got your Windows updates rolled out. That's not the guy that fixes your IP problems. So I think we need to be talking about whether it's IP guys or whether it's broadcast guys. I would say that we need both. I'd say that in smaller operations like the trucks, or fixed installations that are up and running fine, brilliant. Get a broadcast guy, train them up. But if you're talking about something like TPC or CBC Canada or NEP Australia, they're massive, and all I'm seeing is bigger and bigger systems. You won't get a broadcast guy configuring a 40-switch BGP operated IP infrastructure. It's not possible. You need the IP guys to create the infrastructure and to manage the infrastructure. You need the broadcast guys to work out what's going wrong in the broadcast application layer. So I think they both need to understand a little bit about what the other person cares about so that you can have a common grammar and syntax so you can communicate with each other. I think there might be a flooding multicast. It may have a duff address. IP guy can go and fix that. But if you just say, I've got this 12 gigs of rubbish somewhere, what's that? So I think it's going to be a mixture of both. But I think it depends on scale.
And also, I know we won't talk about the security word, but IT training is a lot about understanding security and where the holes can appear in the system. So. Okay, just before I ask my last question, do I have any questions from the audience? One here. Dan, can we...
Thanks. Hi. Obviously, the what is set up in Australia, then St Andrew's Hub, etc., is a fantastic sort of showcase of all your technologies. Actually, I just wondered, there must have been lots of headaches on the way to get to that. I just wondering what if you could share what was your biggest headache really in getting there.
Wow. So I'd like to be able to answer this as NEP, but of course I wasn't involved in building it. Yeah, my biggest headache was the fact that Phil's company got the job. But no, I mean there are always challenges, and it would be a farcical to suggest that there weren't issues along the way. I think the biggest challenge is that a lot of the time we're aiming for the next step, and the next step, and the reality is that we have to bring those realizations in as such. So, it's got to be the latest switch, it's got to be the latest technology, and then of course when we actually go to deploy it, as we all know, that latest technology, that latest switch, that latest thing might have been delayed by issues in production, issues in making things work. And so you can't guarantee that on the 5th of September, everything's going to be perfect as you expected it. Now, I don't know whether anyone else has got a similar sort of thought, but I mean...
I tell you what, all of the installations I've been involved in, and there's a lot of them now. It's not that there aren't any issues in the IP infrastructure, but if you ask any of the guys involved in those installations, they'll tell you the switch was the least of their problems. So the IP bit, the IP bit, I think is pretty well understood, to be honest. That you still need somebody to configure it in a complex manner, but and it's a slightly frivolous answer, but there aren't any. There's no fundamental stoppers really in terms of the IP infrastructure. There's a man nodding here.
Yeah, no, I mean, generally the switch side just works. It's the kit that we're connecting to, it's the configuration of the kit, it's making pieces of equipment talk to each other, and not necessarily on a standard level. It's in terms of, well, I've sent this stream, that piece of kit doesn't understand it. Why is that? What is it that we're doing wrong? Somebody earlier mentioned, IGMP V2 versus V3, all of these things, but that's not a switch side issue. That's always tends to be the end equipment.
That is echoed by my experiences at all the interops. The IP infrastructure is pretty sound.
Just works.
95%, 98% of the questions will be as a result of end devices that have been misconfigured, or a misunderstanding of how they're supposed to work, or a lack of understanding of what a gateway is, or a ... The IP stuff is pretty solid, to be honest.
Does anybody else have anything to add to that?
I think I think you're right. I think when you embark on these projects, there's always the functionality that is available there and then there is the development items which come further along. And generally, what you find with a lot of these big projects, there's always a plan for the development items, but then there's always a mitigation plan of, if I can't get the IP native interfaces on a device, I'll do a gateway wraparound to get the system up and running. The having a plan is always a good thing, but where you tend to find the bits where you're not expecting is maybe some simple interop, where you've gone to an interop and it works perfectly fine, and then for whatever reason, there's been a software update since, and you go to check and that it doesn't work, or there's a pixel offset and it's not quite aligned anymore. And I think the biggest challenge actually is around the control layer, because until we get a common approach to registry discovery and not just connection management, but also parameter control and tally, then it becomes still very beholden on vendors having proprietary device drivers for connecting the endpoints. And that's where you either get permission to control the endpoint, or you end up going through a shim layer to get to the endpoint. And that's where you might find some uncertainty, or it takes you a little bit longer to configure it than you were expecting.
Okay. Robert?
Truth being told, it's like anything new, even for us. We're learning as we go. So through the interrupt, from the R&D, from the projects, and even sometimes our own implementation, we figure out that something got wrong in the latest software update, why it was fine at the latest interrupt when we're on the way, whether it's a POC or a real customer installation. And we all learn on that way. The difficulty is that at some point there is a deadline. There is an on-air date. So whether you double the effort, the only beauty I found in some of the projects we have done is that we have team in Europe, we have team in Japan, then we could work almost around the clock through network connectivity again. As long as you have the VPN access to get a team viewer session open. We had Japan sometimes debugging things overnight. Also, and that's the beauty of the big organizations such as Sony, NEP, Lavo, Arista, and so on, is that we have expertise across the world. So we have to share that expertise, but recognize as well when we fail, so we can fix it and implement the correction later on. So that's part of the experience, and this curve of the pioneers also being in front of us, accepting that we're going to fail at some point. And so far we've been lucky with NEP Australia, because you said in 2017. Most of the products were roadmap for most of the vendors at that time. And starting with that scale of implementation, well done. But they tried it, and we all made it happen. But if we play as a team across vendors, customers, and accepting that we're going to learn, and there will be tough days, there will be tough meetings, but we're going to put the things and the truth on the table. And no one is hiding behind his finger. Because that's the worst thing that can happen is finger pointing. It's your fault, your fault, your fault, your fault.
Silos and points.
And when something gets wrong under high pressure of a project, or live production when you're on a system implemented, you don't have time for finger pointing. No. You have to sort it out. Okay. So that's the mindset you have to.
Excellent. And Daniel, how about you?
Yeah. I think there are always issues on the way, on the path. But one important thing is that vendors collaborate and work together to solve the issues of their mutual customers. And I think this is really happening, and this is a good thing. So the question is not if issues arise, they do. We wouldn't be honest if we would say there are never any issues. But those vendors have to work together. And sometimes you have the point, okay, nothing works, and then you find out it's just because of the dust that had settled on the fibers, because the whole building is still a construction site. Gerard knows what I'm talking about. Yeah.
Okay.
So.
Great. We're running short of time, I'm afraid, because I promised Paul would finish at 4:30 so he can get off on a flight. So I'll just ask you a very, very quick question, if you just give me the shortest answer you possibly can. Just as a last question. To the whole panel, what single piece of advice would you give when moving to 2110? Paul?
Yeah, don't be frightened, because in reality, it's no different to a world where we didn't have hybrid routers. We've got separate video, we've got separate audio, and we've got separate metadata. And as long as you can understand that in your mind, and you understand that the control system will join those things together for you, then realistically, it's perfectly possible to go out and build whatever you need to.
Okay. Jared?
Make sure you engage all of the subject matter experts. Make sure you talk to your broadcast vendor of choice, your network vendor of choice, your control surface vendor of choice, your PTP vendor of choice, and actually make sure you talk to at least two of those, let's say that. Just make sure you talk to all the specialists that understand what they're doing.
Phil?
I'll echo what I said before, treat it like a system. Don't start off thinking it's going to be boxes and you can cobble it together yourself. I think solicit as much information from all the vendors. There's a vast amount of information in vendors. customers. There is never a wrong question or a silly question. Just make sure you treat it as a system, because you can still build an IP system. As an industry, we want to try and get away from these kind of ill-conceived systems where they go out there, they're being bad PR in terms of the reasons for going to IP. I think there's huge potential in IP, but it's got to be built correctly with the right intent, with the right partners. I think it's
Keep educating yourself so you ask the right questions. All implementations are not the same in all vendors. Talk with the expert in the domain. Talk to the pioneers who already made and your peers within the industry, because knowledge sharing, I think, is the cornerstone of what has been done in the broadcast industry for decades. So why change that anyhow? And plan, because network goes well if you architect it well. If you architect it wrong, without talking to Gerard before, you can have the best network switch ever. The multicast will be a nightmare.
Okay. Daniel?
My advice would be build up your own private lab somewhere in your company to try out the new technology, ask the questions, try it out, and make a parallel IP studio to your classical studio that you already have, so that you have time to figure out everything in a practical way.
Thank you. I've been having a little competition with myself throughout the day, and I've been working out what are the 2 best phrases for me for the day. And I have to say, in second place, we've got Gerard's quote earlier. It said, PTP is cool. And I think it is. It's absolutely fantastic. But the winner is Norbert with his sleeping capex. And I think that just sums it up beautifully.
It's coming from my bidding.
But if you could show your appreciation for our panel, Paul Harding, Gerard Phillips, Bill Myers, Norbert Paquet, and Daniel Bolt. Thank you.